In this tutorial, we'll be talking about how to convert fraction and decimal fraction to bicimal. Bicimal is something as binary or base 2. It's a topic under number and numeration, and we are given this question. Um, the first question is 7 over 11 is in base 10, and we have to convert to base 2. Now let's try to solve this question. Solution. To solve this question, 7 over 11, 7 is the numerator and this is the denominator. The numerator is smaller than the denominator, so we say 0 point. So the next thing is to multiply by 2 and keep on multiplying by 2, that is iteration. So 7 over 11 times 2 will give us 14 over 11, and that will be one whole number 3 over 11. So the whole number will be written here, and you take the fraction 3 over 11, you multiply by 2, and that will give us 6 over 11. So the number here is smaller than the number here, that is the numerator is smaller than the denominator, so you write 0. You take the number again, you multiply by 2, and that will give us 12 over 11. This is something as one whole number 1 over 11. So the 1 will be written here, and this will go on and on. So this is in base 2, and that will be the answer for number 1. Now let's look at number 2. Let's change our marker. Now number 2, you have 2 over 5 in base 10 to be converted to base 2. So you say 2 over 5 times 2 will give us 4 over 5. 4 over 5. 4 is a number that is smaller than 11. So this will be 0 0.0. So this 0 point is the default. So because 4 is smaller than 5, so you write 0. So you say 4 over 5, and 4 over 5 times 2 will give us 8 over 5, and this will give us 1 whole number 3 over 5. So the 1 here will be written here. You take this 3 over 5, you multiply by 2 again, and that will give us 6 over 5, and that will give us 1 whole number 1 over 5. So the 1 here will be written here. Take the 1 over 5 again, you multiply by 2, you get 2 over 5, and that will be 0. So this 2 over 5 again, you multiply by 2, you have 4 over 5, and that will still be 0. The 4 over 5 will be taken again, and you multiply by 2, that will be 8 over 5, and that will give us 1 whole number 3 over 5, and you have 1 as a whole number. You have it here, and that will be base 2, and that will be the answer for number 2. So to solve the third question, which is 4 over 7. Now let's look at this third question. The third question will be, we have number 3, 4 over 7 in base 10 to be converted to base 2. That will be 0 point. Then you say 4 over 7, you multiply by 2, you have 8 over 7, and that is 1 whole number 1 over 7. The 1 here will be written here. You take this 1 over 7, you multiply by 2, you have 2 over 7. So 2 over 7, you can see that the 2 here is smaller than this 7, so you have 0. You take this 2 over 7 again, you multiply by 2, you have 4 over 7 is still smaller, so you write 0. 4 over 7, you multiply by 2, you have 8 over 7, and that will give us 1 whole number 1 over 7. So the 1 will be written here, and the iteration will going that way. So that will be base 2, and that will be the answer. Let's look at number 4. For let's change our marker to blue marker. So this is 25 over 32 in base 10. So this will give us 0 point. So 25 over 32, you multiply this by 2, and that will give us 50 over 32. 50 over 32 is same thing as one whole number, 18 over 32. So this one will be written here. So you have 18 over 32 times 2 will give us 36 over 32, and this is same thing as one whole number, 4 over 32, and the 1 will be written here. So this 4 over 32 will multiply by 2. You have 8 over 32. So this 8 is smaller than 32, so you have 0. So you have 8 over 32 times 2. So you have this to be still smaller than 32. So you have another 0 here. And you multiply this 16 over 32 times 2, and that will give us 32 over 32, and that will give us 1. So this will end with 1, and this will be in base 2. So this will be the answer for this in base 2. This is how to convert fraction to bicimal. So now let's look at how to convert decimal fraction to bicimal. You will recall that when we convert these fractions to base 2, we got this, 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 and this in base 2. So this fraction, when you use your calculator, you can have this in decimal fraction. So that is 0.636363. That's why we have these 2 dots. It means that is a recurring fraction. And 2 over 5, we have 0.4 as a decimal fraction. 4 over 7 fraction is 0.571 as a decimal fraction. Then we want to find the answer in base 2. It means that we have to have the same result as this. Now let me show you how we'll get the same result when we convert decimal fraction to base 2. So to convert this fraction to base 2, say solution, that will be 0.636363. So but let's say 0.63 because of these 2 dots, it means it's a recurring fraction. So this will give us let's say this is the answer. So you have 0 points, just like the way we did for the fraction. So you have this number multiplied by 2, 0.63 times 2 will give us 2 times 3, that will be 6. 2 times 6, that is 12. So you write 2, then 0.1. So this one will be here. Then you have this to be 0.26 after taking this one. So this will be 0. So you multiply by 2, you have 2 times 6 to be 12, carry 1. 2 times 2, 4, then that is 5, and 0.0. So you have 0, and you take this 52, 0.52 times 2, you have 2 times 2, you have 4, 2 times 5, you have 10. So that will be 0.1. So you have 1. And that continues like that. You see that the answer we got when we convert 7 over 11 in fraction to base 2 is the same answer we got when we convert the decimal fraction, the same decimal fraction to base 2. We have the same result. So that will be the answer for that. Now let's look at the second part. So the second part will be solution. That is 0.4, and let's roll this line here, and it will be in base 2. So you say 0.4 times 2, you keep multiplying by 2. First start with 0 point. So this will be 2 times 4, that will be 0.8, and 0.8, that will be 0. So you take this again, you multiply by 2, so you have 0. That will be 1.6, yeah, because 2 times 8 is 16, so that will be 1.6. So 1 will be here, so you take this as 0.6 times 2, and that will be, because we have written this 1, so it remains 0.6. So 0.6 times 2 will be 1.2, yeah, 1.2. So you take this one again, so this will be 0.2 times 2 again, that will be 0.4, 0.4, and that will be 0. You take this 0.4, you multiply by 2, you have 0.8, and 0.8, you have another 0. Take 0.8 times 2, you have 1.6. If you multiply that, you have another 1, and this will be in base 2, and the iteration can continue like that, and so on. So now let's look at number 3, and say solution. Say number 3, that will be 0.571 in base 10 to base 2. So you multiply everything here by 2, so that will be 0.571. So you can start with 0.571 times 2 will give us 2 times 1. 2 times 1 will give us 2. 2 times 7 is 14, so if 4, carry 1. 2 times 5 is 10, and that is 11. So plus 1 you carry, that is 11, so that is 0.1. So you write the 1. You take this again, 1, 0.142. Because you have written this 1, it remains 0 here. So you multiply by 2. So 2 times 2 will give us 4. And 2 times 4 will give us 8. 2 times 1 is 2.0. So this will be 0. So you take this again, you multiply by 2. And that will be 2 times 4, 8. 2 times 8, 16. Write 6, you carry 1. 2 times 2 is 4 plus 1, that is 5.0. You write 0 again. So you have 0.568. You multiply by 2. So that will give us 2 times 8. That will be 16. Carry 1. 2 times 6, that is 12 plus 1, that is 13. You write 3, you carry 1. 2 times 5, that is 10 plus 1, that is 11. You write 1, you carry 1. So this will be 1. And you take this as 0.136 multiplied by 2. So this will be 2 times 6, that is 12. You write 2, you carry 1. 2 times 3 is 6 plus 1, that will be 7. And 2 times 1 is 2.0, and that will be 0. So you can actually stop here, or the number can continue indefinitely. So this can be taken again as 0.272 times 2, and we have 2 times 2, you have 4. 2 times 7, you have 14. 4, carry 1. 2 times 2, 4 plus 1, that is 5.0. You can have another 0. You can have 0.544 times 2. You have 2 times 2, you have 8. Then this is 2 times 5, that is 10. So 0.1. So you have 1, and that's continue indefinitely. Let's look at the fourth question, which is solution. That is 0.781 in base 10 to be converted to base 2. So this is a decimal fraction. We want to convert a decimal fraction to base 2. So we have 0.7. You start with 0.781 times 2. You multiply by 2. So that will be 2 times 1, 2, 2 times 8, 16. So 6, you carry 1. 2 times 7 is 14 plus 1, that is 15. So that is 5.1. So you write this one here. The one here will be written here. So this will be left as 0.562. You multiply by 2. So 2 times 2 is 4, and 2 times 6 is 12. So that is 2. You carry 1. 2 times 5 is 10. That is 11. So you write 1. So this one is written here. This will be left as 0. 0.124 times 2. So that will give us 8. That is 2 times 4. 8 times 2, that is 4. 2 times 1 is 2.0, and this will be 0. So the next will be to take this number, you multiply by 2, and that will give us 2 times 8 is 2 times 8 is 16. You write 6, you carry 1. 2 times 4 is 8 plus 1, that will be 9. 2 times 2 is 4.0, and that will be 0. You have 0.496 times 2, and that will be 2 times 6, 12. 2 times 6 is 12. You write 2, you carry 1. 2 times 9 is 18, plus 1 is 19. You write 9, you carry 1. 2 times 4 is 8, plus 1 you carry, that is 9.0. So you have another 0. So you have 0.992 times 2 will give you this is 4. This is 2 times 9, 18. You have 8, you carry 1. 2 times 9, 18, plus 1, that is 19. So 9.1, you have 1 in base 2, and that will be the answer for the last question here. So this is how to convert from decimal fraction to bicimal or base 2 or binary, and you can use this method for any question that has to do with conversion from fraction to binary or from decimal fraction to binary respectively. If you've been following the tutorial, you can now solve this question. It says convert 3/8 as a fraction to bicimal and convert 0.375 as a decimal fraction to bicimal. 3/8 is the same thing as 0.375. Let me know your answer in the comment section. Please press the notification button and subscribe to this channel so that you'll be the first person to get our video. Thank you.